Welcome to Epione Biotech. In this video, I will be going over the design of the handle component of our handheld suturing device. This is what the whole handle looks like in the isometric view. So once you open SolidWorks, make sure that the units are in IPS or in inches. And we're going to start sketching on the two-dimensional front plane. The way the handle was created was by creating a box with these dimensions, which were determined based on the average size of a hand, with the vertical length corresponding to the length of an extended thumb plus the width of the palm, and the horizontal length corresponding to the length from the middle finger to the wrist minus an inch to account for the nozzle at the end of the handle. A center rectangle was used to create this box so that the origin is in the middle. The depth of the box was extruded 2 inches mid-plane due to its ultimate symmetry and to account for the inner mechanisms that would need to fit within the handle. With the box just created, we're going to create the curves of the handle to give it a proper shape and make it ergonomic. So a starting point was chosen relative to the nozzle, whose circular geometry is centered at 4.85 inches from this corner. The point nearest to the circle for the nozzle needed to be below the circle itself, since we knew the radius of the circle was about 0.56 inches as seen by the construction line, 4.29 inches from that corner, which if we subtract from 4.85 inches positioning the center of the circle, gives us 0.56 inches. We accounted for the curved portion of the handle to be 0.6 inches below the center, as indicated by this third construction line. The dimensions of the curves corresponded to an ergonomic fit for the surgeon's hands to account for most minimal hand sizes. The endpoint of this shape was determined to be 2.3 inches from this corner, which would be the length of the curved fingers wrapping around the handle to the wrist. From there, 2 lines from each point, one right here and one right here, were made and connected through a series of tangent arcs, as you can see here, to create the curved shapes of the handle. This sketch was then cut extruded through all. And as you can see, this is the cut that it created through all here. So the next part that was made was the curved shape of the back part of the handle. Here, a tangent arc was sketched coincident from the endpoint of the last sketch, right here, with a radius of 1.25 to account for an average grip diameter. This center line acted as the endpoint of this curved sketch and corresponds to the center of the nozzle, where the side dial and nozzle hole would ideally be aligned. Larger tangent arcs were used to connect the endpoint and the start point of this sketch. This line was sketched to run parallel to this line and coincident with a center line going through the origin of the sketch. This allowed for a certain level of parallelism with the front curved feature and overall give the handle an elegant design. Once the sketch was created, it was cut extruded through all. So as you can see here, we have this cut extrude from the previous sketch made and from the first sketch made here. And now, after that, the opening for the top dial was made. The dimensions for this opening were determined based on the placement of all the other inner mechanisms. Since the side dial would be placed towards the back of the handle and the top dial is responsible for the 360-degree movement of the rods, it was better for the placement of the opening to be closer to the nozzle to allow for space for the side dial mechanism. The length and arc dimensions were determined by the gear size of the top dial. The sketch was cut extruded through all. So as you can see here, this is the resulting cut of the opening for the top dial. To create a smoother, ergonomic design for the handle and ensure better gripping, the entities of the lower part of the handle that was previously sketched right here and here were converted and cut extruded 0.35 inches on both sides. So as you can see, that's one side and that's the other side. And the remaining depth of this lower portion was 1.25 inches. Similarly, the entities of the middle portion of the handle right here, as you can see on both sides, that was previously sketched right here, this sketch that was previously sketched right here, were converted and cut extruded 0.125 inches on both sides for a remaining depth of 1.75 inches. To further contribute to the smoothness and elegance of the design, fillets were applied between the lower and middle portions and the middle and upper portions of the handle. Since the difference between the lower and the middle portion was 0.5 inches, first, these two 0.25 inch inches fillets were applied to accommodate that spacing. To connect that fillet to the middle portion, these 0.45 inches fillets were applied. Since the difference between the middle and upper portions were 0.25 inches, these fillets, right here and right here, were applied to accommodate that spacing, and these fillets, right here and here, were applied to connect this fillet to the top face. The next part that was created were the curved surfaces of the top of the handle. 2 tangent arcs were used for this sketch, which connected coincident from the center of the nozzle, indicated by the center line, to the end of the opening for the gear. Same as on this side, a tangent arc coincident to the center line relating to the nozzle, and then coincident to the opening for the gear. And then these sketches were cut extruded through all. So as you can see, this is the resulting curved surface of the top of the handle. To further contribute to elegant ergonomic design, a small bump was made at the lower portion of the handle where the fingers would lay in order to allow for easier placement of the fingers. A 3-point arc sketch was made coincident with a line corresponding to this edge, so this one right here, and defined with a radius of 4 inches. The sketch was extruded 1.25 inches all the way through on the lower portion of the handle. So at this point, besides the nozzle, the outer features of the handle had all been created, so it was shelled, as you can see here, 0.1 inches to allow for further designs within the handle. Now as you can see, it shows that only this portion of the handle has been shelled and this part is actually filled. This comes later in the video, however at this point the whole handle would be shelled. In the section view you can see that the whole handle has been shelled, even this lower part. But to allow space for the inner gear that will be rotating, with the top dial, a boundary cut was made between the top surface of the curved surface right here and the bottom surface of the curved surface right here to provide a gap that would allow the inner gear and top dial to come together. So as you can see, this boundary cut created a little opening right here into the shelled portion of the handle that will allow the inner gear to connect to the top dial right here. To create the nozzle, a reference plane was made at a distance 1 inch relative to the rectangular face of the nozzle here. This is where the nozzle would connect to. On this plane, a circle with a diameter of 1.125 inches that was tangent to a converted entity of the bottom edge of the rectangular face was sketched. This dimension corresponds to the size of the rod to handle connector piece that would go through it. In order to align this nozzle with this rectangular face, this center line was made that was correspondent to the center of this line right here. This circle was fully defined by having the center of the circle coincident with this center line. Then a 3D sketch was made with a spline to connect one corner point of the rectangle to the circle, 0.24 inches from the top center of the circle, right here. This is the top center of the circle, and this is where the spline connected. This dimension was determined by the symmetry of the handle in relation to the circle. Then, to maintain symmetry, that spline was mirrored relative to 2 reference planes. The first one was coincident with the front plane, and the second one is coincident with the center of the circle and perpendicular to the center line running through it. As a result, 4 identical and symmetrical splines were produced at each corner point of the rectangular face. So, for this plane, this spline was mirrored to result this spline, and for this plane, this spline was mirrored across this plane to produce this spline, and this spline was mirrored across this plane to produce this spline. The splines were then used as guided curves for a loft extrusion between the rectangular face and the closed circle. A loft extrusion was specifically used in order to provide the best amount of material between the handle and nozzle and contribute to the handle's ergonomic design. Once this extrusion was made, another circle was sketched concentric to the circle previously sketched, leaving a 0.1 inch gap between them. This circle was cut extruded 1.5 inches towards the handle to create the hole in the nozzle for the rod to handle connector piece going in. Here's the cut extrusion for the hole that is 1.5 inches, and since the handle is hollow, this will make it a full opening for the rod to handle connector piece going into it. To prevent the inner gear from colliding with this wall, a rectangle was added to one side of the sketch of the opening for the top dial of 0.26 inches. Now between this and this is 0.1 inches, as the outer radius of this is 0.35 when the previous radius was 0.25. So this sketch, this resulting rectangle, was then calculated from the dimensions of the gear and cut extruded through all. However, this resulted in an awkward hole in the opening, so another sketch was made over that rectangle and extruded 0.1 inches on both sides, as you can see here and here. Here's the other side, same rectangle sketched over the previous rectangle and extruded 0.1 inches towards the inside of the opening. To correct this process but still replicate the results on the other side of the opening, the same rectangular sketch was made on a reference plane here that goes coincident with the front plane, and then mid-plane cut extrude of 1.8 inches, leaving 0.1 inches of material on both sides. For reference, this is what the cut extrude looked like, such that there was 0.1 inches of material left on this side and on this side as well. Before creating the area where the side dial would reside at the back of the handle, a fillet of 0.15 inches was applied on this edge and this edge. The dimension for this fillet was based on the diameter of the side dial corresponding to the width of this face and the appropriate space that is needed in order for it to fit. This resulting rectangle entity was converted to a sketch and cut extruded to 0.1 inch since the handle is hollow now. Here is the resulting opening for the side dial that is aligned with the opening for the nozzle. The top dial is designed with an axle for it to rotate around and stay in place once positioned in the handle. So a 0.3 inches diameter hole 0.28 inches from the top of the handle was created in the center of the opening for the axle to fit through. This hole is cut extruded 0.15 inches. The same sketch was made on this side of the opening with the 0.3 inches diameter of a hole that is aligned with the center line 0.28 inches from the top right here and cut extruded 0.15 inches this way. To account for the physics of the handle and how it would remain balanced with all the weight and forces acting outside the handle, more material was added at the bottom of the handle in order to give it more weight. So at the lower portion of the handle, the entities were converted into this sketch and then extruded up to the surface of the opposite side. When we look at it from the front plane, this part of the handle was converted entity and then extruded up to this surface, so that this entire 1.25 inches depth was filled with material. In relation to keeping things in place, the side dial also needed an axis of rotation that allowed it to rotate in place. Taking into account how much of the side dial we wanted sticking out of the handle for the user, 2 1-inch extrusions were made relative to the entities of the upper portion of the handle in a front plane section view. So as you can see, this top part of the section view was converted entity, and a line was made right here that was 1.63 inches away from where the side dial would hang out. This whole sketch was boss extruded an inch because that's where half of the handle would be. The same thing was done with the bottom portion, such that this line right here in relation to this converted entity would be 1.46 inches away from the edge of the handle and 0.31 inches tall, such that the gap between these would be enough to accommodate for the dimensions of the side dial. This was also extruded 1 inch in order to have an extrusion that is halfway through the handle. These extrusions were mirrored about the front plane to create a full extrusion across the handle. Just for reference, here's what it looks like: the front plane and an extrusion such that the other side of the handle that is not seen in the section view can also be filled with material. However, this extrusion resulted in material on the outside of the handle that is unneeded, so the resulting extrusions outside the handle were converted to a sketch entity and cut extruded through all in order to eliminate it. This is also seen here with a little bit of material that came from the extrusion cut extrusion. When this bottom extrusion was made, there was a small gap right here that needed to be accommodated in material. So the rectangular face below was converted to a sketch entity, and boss extruded 0.38 inches downwards, just enough to fill that space. However, this resulted in excess material on the outside of the handle. So that was cut as well. As you can see here, cut extruded as deemed necessary. For me, it was 0.88 inches. All these cut extrudes right here are corresponding to the material that had to be removed on the outside. For instance, this was a really small material that you can see here that had to be cut. This was material within the top portion of the extrusion that had to be cut. To create the holes for the axle of the side dial, a circle of 0.28 inches in diameter was sketched using the right plane section view at a position where the center of the side dial would be on the top and bottom extrusions that was previously made. The top circle was cut extruded 0.2 inches due to the amount of space in the boss extrusion, and the bottom circle was cut extruded 0.3 inches. So for instance, these numbers 0.9 inches, 0.64 inches from the edge were determined by the dimensions of the side dial, such that the axle would be positioned so that there are portions of the side dial outside for the user to use. So as you can see, this top circle was cut 0.2 inches on the top extrusion. The bottom circle, with these dimensions of 0.28 inches and 0.47 from the edge, was cut 0.3 inches below due to the amount of material in the extrusion. Lastly, to provide the rod to handle connector piece going through the handle and connecting with the gear with some support, more material was added where the nozzle met the handle inside the handle, right in this portion right here. This was done by creating a section view on the front plane and converting the entity where the handle is shelled by the nozzle and extruding it 1.5 inches to give the piece a total of 2.5 inches of support. This total extrusion can be seen right here. Then, to provide a continuous opening for the nozzle, the circular entity of the extrusion was converted and cut extruded the same distance. As you can see, this circular portion was converted into an entity and then cut extruded all the way through for a continuous opening of the nozzle. And that is Epione Biotech's suturing handle. Thank you. For the purposes of printing and assembly, the handle was broken into 3 components once completely made in SolidWorks. The first component that's made from the handle is made by sketching on the top plane of the handle using a center rectangle that is centered at the origin. You define this rectangle such that it is wider and longer than the handle itself. So in this case, I'm going to make this 10 inches and this 11 inches, let's say. And then it will be cut extruded upwards through all, this part remaining. However, for printing, we just want this part, this face right here. So we're going to sketch on the front plane and convert these entities of the handle, of the remaining part of the handle. And since this sketch is in the middle of the component, we're going to extrude cut mid-plane 2 inches so that the first component results in what is seen here. The second component is made by sketching on the front plane of the handle. In a similar way, we use a center rectangle centered at the origin and make a rectangle bigger than the handle itself. In this case, again, I'll make this 11 and this 10. These dimensions are arbitrary as long as it's bigger than the dimensions of the handle. And we're going to extrude cut this in this direction 2 inches so that we're left with 1/2 of the handle. For the third component, we're also going to be sketching on the front plane using a center rectangle centered at the origin, making a rectangle larger than the handle itself. Again, I'm just going to make it 10 inches by 11 inches to define this rectangle. And then we're going to extrude cut in the opposite direction of the previous cut so that the resulting cut gives us the other half of the handle. And those are the 3 components that are needed and made for printing and assembly.